similar to the one that somebody else asked from a different worksheet at the start of class. It's the one where we're trying to figure out what values of x make this conditionally convergent. So what you need to do to start off is figure out when it's absolutely convergent first. So absolutely convergent would be when the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n is less than 1. So a sub n plus 1 would be an x plus 2 to the n plus 1. You okay with me separating them like that?
Wouldn't we want to know what the absolute value of it is divergent? Because, like, doesn't it have to be divergent first to be conditionally convergent?
We'll get there. We're going to work it like we're trying to figure out where it's absolutely convergent first, and then based on that, that'll tell us what else to check.
Okay.
But are you okay with this n plus 1 n plus 1 and I split it apart? Okay. And then this would be n plus 1 divided by a sub n. Okay, and then if I figure out where that's less than 1, I figure out where it's absolutely convergent. Again, I realize that's not the question, but that's still the first part of this process. So there's way too many things going on in here for me. So I would put all of the n stuff up front to make the limit easier to see. All the, those cancel. And then all of the x stuff behind. Because the limit only applies to the n things. And again, 9 times out of 10, these degrees are going to be equal, so you're going to put leading coefficient over leading coefficient. All of this just goes to 1. So now I want to know, when does the absolute value of x plus 2 less than 1, which is when x plus 2 is less than 1 or greater than negative 1, and subtract 2 from everything. You get to here. Okay, are you okay with what I've done so far? Okay, so again, this is the absolute converging is this. Now notice it does not include the negative 3 and it does not include the negative 1. So those are not absolutely convergent, but those are the two places it might be conditionally convergent. So now that I realize x equals negative 1 might be convergent and x equals negative 3 might be convergent, I'm going to work those as separate questions. So let me get some more space. So x equals negative 3. So if I put a negative 3 in for x, the question now looks like this. Okay, do you know if this converges or diverges? Okay, so this is the alternating harmonic series, and the alternating harmonic series always converges. So I would recommend memorizing that one. If you don't want to memorize it, you got to do the 2 parts of the alternating test. The limit as n goes to infinity of 1 over n needs to be 0, and it is. And then for 1 over n, each of the terms have to be getting closer to 0, which it is. So even though x equals negative 3 was not absolutely convergent, when I plug in negative 3, I can see that it does give me something that's convergent. So I know x equals negative 3 has to be part of my answer, which is not any of those. So technically you should really test negative 1 also. And if I plug in a negative 1 here, you get 1 to the n, which is always 1. I just want you to see this, not that hard to test. If I put negative 1 in for x, you end up with this. And this obviously diverges. So x equals negative 1 you shouldn't pick because it's not converging at x equals negative 1. So it's certainly not conditionally converging. So are you okay with the first part now? You have to, even though it's not absolutely convergent, you have to do that to figure out which of these two to test out. So